is we're on page 18. And my question to start this is, do we think the cosine of some angle plus another angle would just equal cosine of x plus cosine of y?
I would say yeah. Now she's going to say no.
I mean, do you think I'd make it a question if it was true? You know what I'm saying? It seems too obvious, right? You're like, oh, yeah, of course that would work out. I'm going to prove to you why it doesn't, unfortunately. Because wouldn't that be ideal? You're like, cool, distributive property. I'm good with it. I wish that it was that easy. Let's just prove something real fast. Let's pick any. So whenever something is in the parentheses after a sine, cosine, or tangent, it means the angle. So how about you pick me an angle for x and an angle for y, and we're going to plug them in and see if that left side does equal the right side. So let's go pick an angle. I'm going to show you, I'm going to give you the unit circle to go from. Which angles do you want to use? I don't care. I do typically try to stay in the first quadrant just to make our life a little less miserable. Give me any two angles, and could you please do them in radians? I don't care. Do we agree with pi over 3 and pi over 6? Are we okay with it? Yes. All right, let's go with it. Pi over 3 and pi over 6. So I'm going to say my x is going to be pi over 3. So I'm going to say the cosine of pi over 3 and the pi over 6. That's what you just said your x and your y are, right? And we're wondering, does that equal the cosine of pi over 3 and the cosine of pi over 6? We're like, dang, I really wish it, I mean, it makes sense. I wish it would. Let's just double check. Let's simplify this left side. Pi sixths plus pi thirds.
We can multiply the left side by 2.
I agree, just to get some calm downs.
It's going to be 2 pi.
It's giving 1/2.
It's going to be 1/2 or 1/3 pi.
So you're saying this would be 2 pi over 6 plus 1 pi over 6.
It is giving 1/2 pi.
Is cosine of 3 pi over 6, which is,
Jesus.
that's all right.
Still giving 1/2 pi.
We good? We good? We good? We good? It is the cosine at 1/2 pi, y'all. Yes, Sammy. The cosine at 1/2 pi, the x coordinate at 1/2 pi is 0. So, do you agree this left side is 0?
Yeah.
We're going to go see, does that equal the right side? What's the cosine at pi over 3? The cosine at pi over 3 is 1/2. We need to add to that the cosine at pi over 6.
Which is a root 3 over 2.
Okay, so I'm going to go put that in my picture. So you're saying the cosine at pi over 3 was 1/2. The cosine at pi over 6 was root 3 over 2. This is a good reminder of how we can add or subtract roots. Close. Close, close, close. What if I said 2/4 plus 3/4? What's that going to get me? 5/4. So what's 1 plus root 3 over 2?
1 plus root 3 over 2.
Thank you. I actually just said that out loud, didn't I? 1 plus root 3 over 2. You guys, we just can't forget about our 1. If we multiplied them, I agree, Philip, it'd be 1 times root 3 would get me just root 3. But don't forget about my cute little 1. Are these equal? No. So I want you to go back in between every equal sign. We put a slash through it. Those do not equal. Do I wish they did? Absolutely. Because they don't, anytime we have two angles being added or subtracted here, we cannot do this. Look what we have to do. It's okay to vomit. You're allowed to gag. Here's what I'm going to tell you. I'm never going to make you memorize that. Can I get a whoop whoop? Okay, never going to make you memorize that, okay? I just need us to be able to apply it, okay? So let's just even so any time that I've got two angles being added or subtracted after a cosine, I've got to use this. It's called a sum and difference identity. What do you think sum and difference is referring to? Yeah, I could add or subtract these angles. Then let's look at what the heck is going on here. Again, I'm never going to make you memorize this. How would I say this is the cosine of alpha, how do I say that? Plus or minus beta equals the cosine of alpha, cosine of beta. That's a multiplying in between. What about that?
Plus or minus.
Minus or plus? That's a minus plus. I know, you've never seen that in your lifetime.
That is crazy.
So, you know I like to use the term plinus over here.
Linus.
This is like mind pull, and I'm not here for it. It's not cute. Plinus, so fun. Now, what does this even mean? Yeah, Beck, why would they do that? Well, here's what I want us to do. We've got to go, let's go do this exact same problem, what we were doing, and let's apply this formula, and we'll see how the heck does a minus plus affect it. So you guys, let's go back to this side. We know this side is 0. I want to go see if I can go get it, that 0, using that formula. So we're going to do the same formula. Here we go. We're going to use that same problem that we just made up. Beck chose those radians from the unit circle, and I'm fine with it. You're welcome. So we got pi over 3 plus pi over 6. I would start with that. You guys, I just wrote this right there. Do you agree we've got an alpha plus a beta in our case? So if I were you, underneath it, I'd write that alpha plus beta. I think betas are so fun to write. If you wanted to write A and B, please do. I don't care. The reason I wouldn't write X and Y is because these variables match together. So, but an alpha, an A and a B, I think that you could still match. An X and Y might be harder. Yeah, it's just an elongated. We go, woo!
Wow, that was, yeah. You got it. Oh, spelled it wrong.
I did not. Here we go, peeps. We have got to go apply this side now. We've got the left side set up. Which track did we go? On the plus or minus? Are we on the top shelf or bottom shelf, if you will? Right here. We're on the top what? Bins. Okay, yeah. So we're on the top bin. So what that means, Braddock, is I must stay on the top bin throughout the problem. If, Braddock, I chose a alpha minus beta, I'd stay on the bottom bin and I'd use a plus over here. Great call. Okay, here we go. So we got the cosine of, what was our alpha? What was our alpha? Yeah, thanks, Dow Dow. Times the cosine of my beta. What was my beta?
It's going to be a whopping 5 or 6.
And then I was top bin. So I'm going to stay top bin, which turns this into a minus
A sine of pi over 3.
sine of pi over 3.
And a sine of pi over 6.
Right. Here we go. Cosine of pi over 3, help me out. Cosine of pi over 3, boom, what is it?
You just...
Graham Wilson, I agree, I know. Cosine is just the x, it's not sine. Guys, what's the x coordinate at pi over 3? Thank you, Dowdy. Huh, what'd I do without you? Cosine at pi over 3 is a half. Times the cosine at pi over 6. Thank you, Philip. I'm about to move my chair. The sine of pi over 3. Sine, it's the y coordinate there. Root 3 over 2. Times the sine of pi over 6 is 1/2. Whew. Guys, we haven't done too much of multiplying and things with roots, so here I am to help you. When you multiply fractions, we go like this. Boop, boop. Anything on the outside of a root stays on the outside. Anything on the inside of the root stays on the inside. So 1 is on the outside. 1 times root 3 would get me...
1 plus root 3. No, 1
Hold on. Don't jump ahead. 1 times root 3 is going to get me root 3. Over 2 times 2?
4.
Minus root 3 times 1. Root 3 over... Guys, what is root 3 over 4 minus root 3 over 4? 0. We knew before, on the left side, when we just solved that left side, we got 0. When we applied this formula, we still got 0. We did it. That was not easy. I know that wasn't easy. But y'all came here with an open attitude, and I just appreciate it. I feel like that went great. Now, looking at this problem, it said, hey, find the exact value of the cosine of 735 degrees. Correct me if I'm wrong. We don't know where that is on a unit circle. 735. How would I figure out where 735 degrees is?
Minus 360.
Minus 360. 735 minus 360.
Minus 360.
Minus 360
I know where that is.
is 15 degrees on my unit circle. Is not there, but to your point, you're like, I know where it would be. I know where it would be. And it said, what's the cosine? We don't know what the x-coordinate is, so we're going to go find it out. Here's the deal. We don't know what the value is. So can we add or subtract 2 angles to get 15 degrees? Let me back this up 1 second. I'd like everybody to write this. They wanted us to find the cosine of 735. Is that going to be the same as the cosine of 15 degrees? Yeah, they're coterminal, and let me just prove that to you real fast. I'm in degrees. If I hit cosine of 735 and I hit the cosine of 15, guys, it's going to be the exact same thing. We need to use our unit circle. Thank you. These are the exact same thing. Here's what we need to do now. I'm going to go get this formula and I'm going to bring it down just so it's staring us in the face. This is the most uncomfortable part for kids to start, in my opinion. We need to figure out, hello, we need to figure out, okay, two angles that we can add or subtract to get me 15 degrees.
45 minus 30.
Is 45 minus 30, 15?
Yes.
Okay, what's another way to get 15 degrees by subtracting two angles? Is 60 minus 45? Graham, stay tuned in.
You're like whispering in my ear.
60 minus 45 is 15. Could I do 135 minus 120?
Yes.
Could I do 225 minus 210?
Yep. Yeah.
You could do any of those. I think it is easier when we stay in the first quadrant. Which one do you want to do, 60 minus 45 or 45 minus 30? It makes no difference. 45 minus 30, here we go, people. Is the cosine of 15 the same as the cosine of 45 minus 30? Have I changed anything?
No.
45 minus 30 is just 15. That's like me calling Dicey, Aiden, whatever. It's all the same person. Here we go. We're now going to go apply this formula that I don't know where it is. Why can't I grab it? Oh, bother. Where did it go? Oh, boy. Oh, geez. You.
Okay.
You.
Okay. Wow.
Here we go.
Wow, that was aggressive. All right.
Here we go.
Oh, bother.
Okay. You guys, we got alpha minus beta in this case, don't we? Oh, snap. Alpha minus beta. So, you guys, if we're on bottom shelf, you agree we got to go bottom shelf over there?
I like this.
Yeah? Okay. Let's do it. Thanks, Tickner, right on my desk. What's that going to equal? The cosine of what first? Cosine of alpha minus beta. Look what I just did. 45 and 30 are my alphas and my betas. So cosine of 45, thank you, times the cosine of 30. In my last class, they asked so many good questions. They said, wait, is it negative 30? You guys, this negative only refers to this sign in here and tells us if we go top or bottom shelf. The first number is my alpha. The second number is my beta. The sign in between just goes right here. Cool? So because we went beta bottom shelf, we're going to use plus over here. You guys okay with that? Yeah? And then we've got sine of times the sine of 30. Yeah? Now all we do is we use that unit circle, guys. We just need now the cosine of 45 in degrees. I'm sorry, cosine of 45. Boom. What is the cosine there?
Jesus, root 2 over 2.
Root 2 over 2. Times the cosine of 30. Root 3 over 2 because it's the x-coordinate plus the sine at 45. Root 2 over 2. The sine at 30 is 1/2. This is some good practicing of my roots. What we can do. When they're under the root, they both get to stay under. What's root 3 times root 2? Root 6 over 4. When you multiply, you do multiply straight across on the bottom. Plus, great. Do we have condoms?
We do.
Okay, I need you to know. Root 6 is like an x. Root 2 is like a y because they don't have the same root. We would just say x plus y is just x plus y. So I'm going to say root 6 plus root 2 all over 4. That's my final answer. If I had, let me just back this up real fast. If I had, so you guys, what if I said 1 root 6 plus 3 root 2? You guys, I couldn't add those still. That's as far as I could take it. What if I said 1 root 6 plus 3 root 6? Then we've got 4 root 6 because again, these roots are just like an x and a y, and when the roots match, 1x plus 3x is 4x's. So
What if we
Here we are. We're going to just do this problem. Take that out of your vocab. Tangent of 285. Is that on my unit circle?
What is the example?
285. 285 degrees? Wouldn't it be somewhere here? It's not there. But could I add or subtract two angles to get 285? What could I add or subtract? Let's go in degrees to get 285.
You can add 240 plus
45.
Okay.
240 plus 45 is 285. Do a different one.
225 plus
225 plus 60 is 285.
210 plus 75.
And is 75 on my unit circle. So 75 is not on my unit circle, so that one's not going to help me.
Literally stop right now, dude.
315 minus what?
I don't even know. Minus 30.
Minus 30 would get me 285. I'm going to say these are all equal to 285.
270 plus 60 minus 45.
280.
Hey, okay, Graham.
Okay, good. I can only do two angles, though. I love that, though.
You try.
I love you a lot. That was great. He's like, add one, subtract that, multiply. We're there. Okay? Okay. Give me another. How else can I get 285?
135, 150.
Oh, 135 plus 150 is 285. Stop. What about 330 minus 45? Is that 285? Here's what I'm saying. Any of these work. I don't care which variation you use. Lucas Schmid, you want to go 1, 2, 3, 4, or 5? It makes no difference. Which one do you want to go? 5. He goes, yeah. 330 minus 45. I dig it.
Attaboy.
Here we go.
Love it.
We're going to use 330 minus 45 as my alpha and my beta. I'm not listening back. Write this down. Nope. I can't answer that. I don't know. Write small.
I don't write small.
Well, change. Yeah, we sure did. We're going to come back to that on Monday. You guys, I want you to say the tangent of 285. That equals, we said what minus what? Lukey, which one did you pick? 330?
Yeah.
Minus 45. Thanks, bud. You guys, have I changed the problem? No. 330 minus 45 is the same as 285. You guys, underneath that, I'm going to write alpha minus beta. Oh my gosh, they asked for the tangent of an angle that is not on my unit circle. So I'm going to use this tangent formula. Whoa. I am not going to make you memorize this ever. Can we apply it? Do we have that grit? Do we have that perseverance? Can we apply to this? You guys, we've got alpha. We chose minus beta. Which bin are we in, Grammy? We're in the bottom bin. Boom. So I'm going to go through and we're going to only use the bottom bin. Minus then a plus. Okay, here we go. Tangent of what's my alpha?
330.
On the top. Then we do plus or minus. Which one? Minus. Tangent of my beta, which is?
45.
Yeah, all over. 1 plus. The bottom is now a plus sign. The bottom bin. You know what I'm saying, people? Tangent of
330.
times the tangent of?
45.
Thanks, guys. Okay, here we go. Tangent of 330. Don't be mad at me. Don't be mad at me. You can be mad at Schmid.
Thank you.
Tangent at 330. Ooh, what is it?
Ew.
Oh, this is an...
Negative.
Why do we put the tangent coordinate on the unit vector?
Oh, that would be
Why do we always like, I mean, it's always the same.
Philip.
Did you just hear that? This was turned.
I did not. I'm not listening. Here we go. Tangent at 330.
Root 3 over 3.
I'm not looking at you, Bradley.
Negative root 3 over 3.
Right. Now, hold on. People take time. People take time. So the tangent at 330, I'm going to just write this chicken scratch down here. It would have been this. It would have been that y over x. Do you agree my 2's cancel?
Yeah.
And I would have been left with negative 1 over root 3. When we multiply by that root, it is negative root 3 over 3. Okay, so that is my tan at 330. I do not need you to write that. Some people might need to write it to help themselves figure that out. That's okay. The tangent at 45.
It's 1.
Thank you.
Do we agree with Philip? Root 2 over 2 divided by root 2 over 2?
Absolutely.
Minus 1 on top, yeah? Over 1 plus. That tangent of root 330, we already found it. What was it? Careful, Philip, you're missing that negative.
No, I said the negative.
Oh. Times the tangent of 45, which is 1. Do I really need to say times 1? I can, but you don't need it. It's not going to change anything. Okay, here's the deal. Here's why I asked you to write small. We got to keep going. This looks good. I feel like you all have plenty of space. What I see in this front row, y'all have plenty of space. Yeah. Oh, wow. You wrote really small. Okay, let's simplify. We've got so much going on here, you guys. Could we get these to be condoms?
Yeah.
What's this guy going to become?
Times 3.
Yeah, you agree 3 over 3 is the same as 1? So if we got 3 over 3, what do I have up top? Negative
1
root 3.
minus 1. All 3.
I'm aware, Charlie.
Wouldn't it be that? What are we doing down here? The same thing. You guys, times 1, this guy is just negative root 3 over 3. So I'm going to multiply the 1 by what? Yeah, 3 over 3 is really just 1. So what do I have on that one?
3 plus negative.
Yeah, you cool if I just write 3 minus root 3? Thanks, dude.
I got you.
Anything we can cancel out. Boom, boom.
We're left with almost the exact same.
We're left, the word almost is very important there. Here's where you're going to feud at me. We're not done. Why are we not done? But then we're almost done with this problem. We're almost there. Guys, I can't have a square root in the denominator. Yeah, bud. Say it. So we have been working with conjugates for a bit. The real, where conjugates really help is when I've got a root in the bottom, multiplying by the conjugate gets rid of the root. The conjugate is always the denominator with just the middle sign is changed. In my last class, they wanted to change everything sign, only the middle one. So what is the conjugate of the bottom? Dowdy, A plus, sir. 3 plus root 3. Let's look at that top. Let's distribute that top. Take your time. Don't shout out early. We're taking negative 1 root 3 times a 3. Anything outside the root stays out. Anything inside the root stays in.
So negative 3 root 3.
Yes. Minus. Ooh. Negative 1 root 3 times a root 3. The negative 1, is outside, so the negative is me just writing that minus. What's root 3 times root 3? Root 9, which is just 3. Then what? Minus? Yeah, minus 9 there.
So can we just do this quickly, or we just do minus 12 instead of...
Sure. Oh, yeah, you can certainly combine. He said minus 3 minus 9 is just minus 12. Perfect.
Minus 3 root 3.
Yes. Anything outside the root? Ooh, okay. You're so right.
Wait, why is it just 3 plus root 3 and not in...
Right here? Yeah. What was your question?
Why didn't we
We're multiplying by the conjugate. So that's of the denominator. You're going to flip the inner sign.
Dude.
Yeah, now we're on the bottom. Ready? What's 3 times 3 going to get me? We got a 9 here.
Root 3 over 3.
Plus root 3 over 3. Minus root 3 over 3.
Cancel that plus 3.
Minus 3. Okay, we're almost there, guys. We're almost there. Picture this as negative 3x minus 3x. That'd be negative 6x. So it's just negative 6 root 3 minus 12 over
6.
so close. What's my final answer going to be? They all have a 6 in common.
So it's going to be a whopping root 3 minus 2. Negative root 3.
Negative root 3 minus 2 over 1, or just negative root 3 minus 2. Agreed. Holy cow.
I feel
let you cancel out here? Graham Wilson, put it away. Why did I let us cancel out? Because there was adding or subtracting.
Because everything.
Everything had it. You didn't just do 6 over 6 and cancel those out. Every single term had it, okay? Now, real fast, I just want to show you why this is not the worst thing you've ever done in your life. Tangent of 285. If I did tangent of 285, is that crazy decimal? Oopsies. It's negative 3.73. Now, if I do negative root 3 minus 2, we know we got it. Whoa. That was a lot.
Check yourself.
Check yourself.